Hello everyone, Mr. Schultz here. Alright guys, so what I'm going to need you to do is I'm going to need you to write 7-2 up in the left hand corner and your information in the right corner. Make sure to write your first and last name. Alright, so our lesson for today is probability and counting. So when we think of intersections and unions, think Venn diagrams. So here's what a Venn diagram looks like. So this would be A, and this is B. Now, in here would be A and B. A and B. So, let's begin. Alright, so looking at this, we see this first one right here. Let me put a little dash right here. The probability of A intersecting B. So the intersection of A and B would be the number of outcomes of A and B. So right here, A and B together divided by the total number of possible outcomes. So the probability of the intersection of A and B, this means the probability of A and B. That means both at the same time, So not one or the other, but both. Now, that's the difference between the probability of A, the union of A and B, the probability of A or B. That means if A happens or B happens, you win. So if I'm like, you know what, I'm really hungry, go get me a hot dog and a hamburger. If you bring me back a hot dog, I'd be happy. If you bring me a hamburger, I'll be happy because I said or. Bring me a hot dog or hamburger. That means one or the other. Now, if Mr. Schultz says, hey, I want a hamburger and a hot dog, and you only bring me one, that intersection didn't work. And I'm not going to be pleased. So and means both, or means either one. So here's this information. How do we find just the information? So like if we want A or B, basically take the probability of A, the number of outcomes for A, and the number of outcomes of B, and you're going to subtract this middle part right here. Why? We'll get to that later. Let's go on. So here's example 1. Finding intersections. A fair die is rolled. So it doesn't say how many dice there is. So we're going to pretend that it is a 6-sided die. Let A be the event of rolling an odd number, and let B be the event of rolling a number greater than 3. Find A, B. Give me a second. So it's asking find the intersection of A and B. That means both. So what's an odd number? Well, that's not even. So if it's 2, 4, 6, 8, who do we appreciate? Not those numbers. So the numbers are 1, 3, and 5 because the numbers 1 through 6. Now B, it says a number greater than 4 or a number than 3. So the number that's greater than 3 would be 4, 5, and 6. So the intersection of A and B would be in both sample spaces. So what is that? Well, looking at this, it looks like it's only going to be 5. So the intersection of both of those would be 5. That's the intersection. That's the event, the one event that they share in common. All right, let's go on to example 2. Now, just a heads up, this might be 3 pages long. If it is, just remember on the next one, don't write notes or work for other lessons with this one. All right, let's go on. All right, find the probability of intersections. What's the probability of rolling an odd and prime numbers on an 8-sided die? So it has the word and. So let's underline it. So I know all the odd numbers. I'm going to write over here. I know 1, 3, 5, 7 on an 8-sided die, so it's a little bit different. prime numbers. Prime numbers are going to be 2, 3, 5, 7. Yeah, that's it. So it looks like the numbers they don't share would be, well, let's circle the numbers they do share. It'd be 3, 5, 7. So 3, 5, 7. So now we can fill in the information. We know that 1 is here, we know 2 is here, and they share the and part would be 3, 5, 7. This is just one way to show this information. Show the sample spaces of A. Let's call this A, and let's call this B. So A and B. A and B would be inside here because it has both. All right, let's go. So the number of outcomes of A and B. Okay, well, how many are there? Let's count. 1, 2, 3. That's it. So this is going to equal 3. Now, if it's an 8-sided die, how many sides does it have? Yeah, let's go on. So if I divide 3 by 8, like 1 is like 12.5. So 1/8 is that, and 1/4, also known as 2/8, would be 25. So this would be about 27.5%. That's the probability, or 3/8. All right, let's go on in 3, 2, 1. All right. Find unions, not and. So what does this mean? This is the or. Or either. So either A or B. If A or B works, they're like, hey man, I don't care. I got something to eat. I got my hamburger. Nope. I got my hot dog. Yep. Doesn't matter. I got one thing. We're good. A fair die is rolled once. So does it say it's an 8-sided die? No. So it's going to be 6 sides. So 6 sides. Let A be the event of rolling a number less than 5. All right. So A is going to be less than 5. So that means 4, 4, 3, 2, 1. All right, now B. Let B be the event of rolling a multiple of 2. Okay, well, this one's going to be 2, 4, 6. So it's saying, hey, what's the probability of this happening? Well, the probability is going to be the total. So let's see. If I have 1, 2, 3, 4, and 6, either one of those, I have 1, 2, 3, 4, and 6, that's 5 equals out of the total of 6. So 5 divided by 6. Now, I'm going to tell you right now, I'm going to need a calculator. So give me a second. All right, so it's going to be 83.3%. However, class, are we okay with just leaving it as 5, 6? Because I would. Just leave it at 5 or 6. The probability is 5/6 of a chance of rolling a number less than 5 or rolling a multiple of 2. All right, let's go on. Last one. Complementary events. Something not happening. So, what is the probability of a spade card in a regular deck not being picked? All right, well, if you don't know, we have spades, and there's 13 of them. We have hearts, and there's 13 of them. And we have clubs, and there's 13 of them. And finally, we have diamonds. I always spelled diamonds wrong. And there's 13 of them. Oh, gee willikers. How many cards are there? There's 52 total. So a complementary event is not it happening, but it not happening. So if I want to know spades not happening, I'm going to take all these numbers and I'm going to put it over 52. Now, I'm going to tell you right now, this is going to be 39. I already know for a fact that each of these is four equal divided decks. So I know it's going to be 3/4. That's the probability of not drawing a spade. Now there's other ones, but for now, that's it. Alright guys, see you in the class.